YouTube channel. Today we are going to look at how we can solve the beams using ETABS. We will be doing the structural analysis of the beams. We will utilize ETABS static analysis, and it's a structurally determined beam. So here are some of the examples of the beam that we can choose anyone. I believe that because this video is just for the beginners, so we will stick with this beam. It's 3 meters of 1.5 meters length of beam with a fixed support having 2 point loads, one of 2 kilonewtons and one of 1.5 kilonewtons at a distance of 1.5 meters. So here is the shear force diagram and this is the bending moment diagram. So we will be verifying this calculation using ETABS, and it's a pretty easy thing. So let's get started. So now we are on the screen of ETABS. Okay. So what we'll do is we'll open a new model. We'll go to file and new model. And when you use the when you need to use the built-in settings in which we because our beam is basically in the SI system. So here we'll utilize this metric SI system. We'll click OK. And for the grid only layout, we will use the custom grid spacing and also the custom story data. We will try to replicate as close as possible the layout of a beam using the grid. Like you can see that we have like 3 grid lines here, A, B, and C. So we will be using the same layout here. You can use the edit click data, and we will be using the display grid data as ordinates. So we don't have to use the spacing. We will use the ordinate. You can use the spacing as well. By spacing, it means that you can see that the spacing between C and B and C. I'm taking this as C to make things very easy for us to understand. So this is, for me, this is B and this is C point. So we each use the distances. You can see that it is 1.5 meters. So if this is 0.5 meters, this is 1 meter. So this is the spacing is 1 meters and 0.5 meters. So we can either use the ordinate or we can use the spacing. It doesn't matter. So we'll go with ordinates, and we see that A is at 0. The B point, sorry, the B point, yes, the B point is at 1 meter distance, and the C point, it is 1.5 meters distance. So we'll delete this one. For the story, for the Y grid data, we just need one, grid. So we'll just keep this. And because, in order to make this layout a bit good, we can reduce the bubble size. So we'll reduce it to 500 or something. Okay, let's make it 250 maybe. Okay, even now it is, let's say 200. Oh, let's do it 150. So now we are okay with it. Our beam layout is there. Now we can go to the custom story data, and we just need one story. I'm just deleting this to make things easier for us. So we'll use only one story, and height doesn't matter. This thing it's irrelevant because we are not just analyzing the beam. So you can click OK now. It will make some standard windows, the perspective view, and the top plan. Now to make things easier for us, we will go to add a new window, and in the new window we want to look at the elevation of the beam. So we can set the elevation view at first grid, that is the one grid, that is the Y1 grid here, along the Y plane. So we'll go with 1 and we'll apply it. Okay, so here it is. We have this, okay, what we can do is we can also modify the, okay, let's leave it. Okay, let's leave it. Well, what we want to do is, this is point A, B, and C. So we have to, now the next step after applying the layout is to draw the beams. So what we have to do is, what sort of beam it is, it's a straight beam with a fixed support. So we will be using this draw beam, You can also go to the menu here, and you can draw the beam, okay, from this section. Okay, here, draw beam column brace. So you can use here. Okay, now we will be drawing this 1.5 meters of beam. Okay, you can press escape here now. Then now the beam has been drawn. The other thing that we have to do is you apply the restraint at this point. We have a one fixed support here. The next step is to apply the restraint. So our restraint is just one, uh, and it is fixed beam. So we will apply. We'll first select the select this node, the grid point A, and then we'll go to assign, joint, and restraints. And this will give you different bunch of options like fixed beam and the hinge support or the pin support, and then this is the roller support. That's the free, and we have this fixed support. So we'll click this fixed support. After clicking, we'll go to apply, and it will apply a fixed support here. So we have drawn the beam, we have applied the supports. The next step is to apply the loading. So we have to select the beam first. It's a simple, loading vertical point loads. It's not anything complex, because you can see here that in some scenarios we have to apply the UDL. That is, we'll cover it in next sort of tutorial if we can make. But for the current tutorial, we just have to add the vertical point loads. So we'll first have to select the beam. So we will select the beam here. You can see the beam has been selected. Now we'll have to go to assign. Okay, before assigning the load, one important thing that we have to do is we have to make its dead load self multiplier as 0. So for that we have to go to define, and we need to go to load patterns. You can see here the dead load self multiplier is 1. So we have to make it 0 and modify the load. Also, for make things easier for us, we can consider that the load that is being applied on the beam is dead load. So we can consider this as WD, and we can self multiply. We can say that it is a dead load and self multiplier is 0. So you can either use the dead load also, or you can define your own load pattern, and you can add that load. And you know if- because once you will be applying the load, you need to select either it is a dead load or a live load or WD. So we'll go with WD now. Okay. Now we have to select the beam, and then we have to go assign frame load, and we have to go to the point load. Now you can see that the load pattern name is here WD, that we have created there. So you can use WD there. It's a force. If there is a moment, you can use this moment option there, but we are going with a force. And now here the two options is that either you can use the relative distance or the absolute distance. So the thing is that if you need to apply the you want to refer to the distances of the beam, you can say that I'm going for the absolute distance, or the relative distance. So for this case, let's say I choose absolute distance. So for the absolute distance, we can see that the distance, this is I and this is j. So the distance of this load from this I point is 1 meter. So we can say that at 1 meters 2 kilonewton load is being applied. So at 1 meter 2 kilonewton load is being applied. So it's okay. The next is 1.5 kilonewton at 1.5 meters of length. So at a distance of 1.5 meters, we can apply a load of 1.5 kilonewton. So that's okay. Now, because we don't have any other load, you can either select add to the existing load, or you can say replace existing load. So it doesn't matter now, because there is no other load applied on this beam. So we can go with this as it is. We can click apply now to check if the loads are being applied. So the loads are being applied, and now you can cross refer your configuration with the original example beam. So we are okay to go. You can click OK. Now we are all things are set. We can now check, and we can run the analysis there. So what you can either press F5, or you can go to analyze and run analysis. It will ask you to save the beam. So we can save it as first final example, let's say. Okay, we can click save. Now it will save, and it will, you can see that it is, running the analysis here. So it is analyzing the beam. So once it will load, it will show the, we will be able to, see the different things. You can go to the display, and then you can go to the sport spring reactions. You can choose all of this. Okay, this will allow you to see that what are the reactions of, what reactions do you have, point reaction. You can activate this window, and then you can click apply. So you can say that we have one vertical force reaction here of 3.5. It is not being mentioned here as 3.5, but what you can see is you can add this up. It's a pretty simple beam. You can simply add this one. It is 2 plus 1.5. It's 3.5. So this is 3.5 of upward force as a reaction, and this is the movement. You can see that the movement here is, it's simple, that you have first have this movement. It is 2 multiply 1, it is 2, and then it is 1.5 multiplied 1.5, so it makes up 4.25, which is this one. So it's pretty easy. It means the calculations are okay. So once you have checked the sport reactions, you can go to the display, and then you can see the uh, see the moment diagram, and the shear force diagram. So one way of doing this is go to this display, and then member force diagram for frames, spear, spindles, links, and here you have to click this moment 3, and you can also show the values at controlling stations, and the window is active. Okay, apply. Now you can see that this is the moment diagram of this beam, which is pretty simple. There is no any special sort of thing. You can see it is 4.25. Okay. Another thing that you can do is you can click on the beam, and then you can click on the beam, so the beam is highlighted. You can see the beam is highlighted. It is selected. You can right click on it to see the uh, shear force and the bending moment diagram. So this is the shear force. You can compare it here. The shear force is okay. Okay, and then you have this movement diagram. So what it is suggesting is that at this C point, the movement is 0.75. So you can go over here, and you can click at this, and you can see that it is 0.75. So that means the calculations are okay. So that's it for our today's video. I hope you've enjoyed it. If you have any questions, you can comment that down below, and I'll try to answer or make any similar videos. But please make sure to subscribe, because it takes a lot of effort to make such videos. Thank you. See you. Bye bye.